This is the introduction to GitHub Actions. Who saw the Brian Douglas presentation yesterday on GitHub Actions? Anybody? All right, then you won't have anything spoiled for you. Now, Brian Douglas is a GitHub, I guess he's a developer advocate now, who does a presentation talking about how they can be used in general. What I want to do today is kind of give you some of the background of it, but also help you understand some of the implementation aspects. And I'll start out by saying this will probably be more material than you might normally want to consume in a 45-minute session, so I'll apologize in advance, but the idea is to get you exposed to some of the concepts around them and kind of how they work so you have that background, and then you can kind of pick up and explore more on your own. So, my name is Brent Laster. I have a training company called Tech Skills Transformation. In my day job, I'm a director at a DevOps organization working for SAS in Cary, North Carolina. Written some books and other things in there. Do some training. There's a Git book you have out on Amazon if you're interested in learning more about Git. Maybe some of you got a chance to look at it yesterday. We did a book signing for it. Jenkins 2 book as well. If you're interested in learning about pipelines as code or Jenkins in general, check that one out. If you do get that one, I recommend getting the electronic version because it has some of the printouts are kind of washed out in the printed version. And if you search for my name on O'Reilly, you'll find a few courses if you're interested in learning about Kubernetes, continuous delivery, Git, any of those sorts of things. So let's talk about what GitHub Actions are. Who here has used GitHub Actions? Anybody? A couple of people? Great. So really GitHub Actions are a way to create custom automated workflows in GitHub. I keep forgetting I have a monitor down here too. That are executed based on events or operations that happen in a repository. So the actions are tied into a GitHub repository, and based on different kinds of events that we'll talk about in a moment, they can react and do things that might normally require you to, for example, to use an API or such to use. They are building blocks into they can be combined and shared. You can chain actions together, do multiple things, and it's really about being able to automate any kind of task you want. Most commonly, we might think of this in the sort of software development lifecycle situations, particularly like CI/CD, continuous integration, continuous delivery. And in that sense, they can be an alternative for some of these other apps that you see up here, Jenkins, GitLab, Travis, CircleCI, all of those. Now, I'm not going to say they're the exact replacement, but they all have their pluses and minuses. But a lot of people think of them in terms of being able to automate the CI/CD process. For example, when I do a pull request into my GitHub repository and I want to have GitHub spin up some sort of a build or test scenario that can validate that the code that's coming into the repository actually is good before it goes all the way in. So what's interesting about it? Well, direct integration with GitHub. That's probably its biggest claim to fame and also probably its most restrictive sense in that it is specifically tied into GitHub and the GitHub repositories. You can actually go into GitHub and there's in the GitHub repository, there'll be a little place you can go into in the code that is under the workflow .github workflows directory. That's where your actions pieces live in there. They live in your repository. You can go in then through the actions menu in GitHub in your repository, and you can look at the actions. You can see the different ones that run, the history and so on. And you actually have a graphical interface as well that, much like you might see when you're chaining together Jenkins jobs or anything like that, you can see the chain of actions and jobs that have run in them as you've executed them. You can also go in and debug. You can go in and see the logs from actions. You can go in and see what's actually happened under the covers. So it's got great integration with GitHub. That's its main claim to fame. And then what else is interesting about it? Well, you can automate pretty much anything that you can trigger off of as far as events. For example, you can automate things on projects, watches, deleting, check runs, page builds, all these different things you see, pull requests, those kinds of things. Now, most of the time, you're probably going to want to do it on things like pull requests, but it's good to know that there's a lot of different kinds of events that you can actually run the actions on. The on keyword here says when this event happens, when I detect this kind of event in GitHub, then I'm going to go off and look for a workflow to actually execute and run. And click through these types of triggers for different events. Here's the kinds of things that you can trigger on in GitHub. A single event, for example, just a push, You can also have a list of events. You could have a push or a pull request and trigger on either one of those. You could have schedule events. There's a cron syntax there where you can actually cron it to run a certain intervals, minutes, hours, days of the week, whatever makes sense for that. There are manual events as well. You can have a workflow dispatch, repository dispatch, things that would trigger the workflow based on some manual process. You can have workflow reuse events. What that means is that you can have one workflow calling another one. So you can have all kinds of different things that you can trigger off of. And the most common one probably is going to be something like a standard webhook event. A webhook, if you're not familiar with that term, is essentially when GitHub detects that something happens and it sends a payload, as we call it, with information about what happened, what changed in there to some other process. So we think about this, for example, if you're using Jenkins, you can have GitHub trigger or send webhook or fire a webhook and send information across the network to your Jenkins instance so that it can then respond to that and pull down the code and so on. This is just webhooks running then within GitHub itself to be able to trigger the workflows. How actions work? Well, we start out with the basic concept of an event. Events occur, for example, a pull request or a push or a commit or something that happens in the repository, a webhook. And we start out with this idea that we have triggered some kind of an event. Now, an event's usually going to be something that simply occurs, and then because we're working in GitHub repositories, has a commit associated with it or a SHA-1 reference of some kind, a branch or tag or something like that. So the information then gets sent out as an event. And within a GitHub workflow, the first parts that we have is this sort of on here that says, when do we trigger this? When do we actually say, oh, this is something we should pay attention to and should execute? And you can see here it says on a push or a pull request for a branch main, only for branch main. That's when we go off and actually do whatever we have inside the workflow and run the jobs. So we have the event piece there. And over here on the right-hand side, this is an excerpt of some of the things that you can actually trigger events off of. This is only a part of them, but you can see this is all the webhook events, the common kinds of things you might choose to have to key off of when they happen in the GitHub repository. Moving on from events then, events can trigger workflows. So a workflow is just a procedure. It's basically like a little program or a script that you want to run automatically. This stuff is written in YAML. Seems like YAML is everywhere these days, but it's basically it's a set of jobs that run something for us. So it gets added to your repository. You can have one or more jobs in there that get executed, and then it can be triggered or scheduled by the event, and it's useful for doing things like CI/CD or whatever you want to automate. So the event then keys onto the workflow, and as we saw, there's that little piece in there, the on part, that says, hey, this is the case where I want you to actually go off and execute what I've got in this workflow. GitHub then, if you go into the Actions menu on your repository, has this list of the workflows. You can go in there and you can select the ones. You can see the different workflows, get the history. You can look at the logs and drill into them and so on. So we have events that drive workflows, and then we have, within the workflows, we have things like called jobs. Jobs are simply sets of steps. Workflow with multiple jobs usually runs them in parallel by default. You can tell that to run them in sequence instead. And jobs contain steps, which is simply a task that can execute the commands in the job. The steps can be either some kind of action or it can be a shell command. So we have inside our workflow one or more jobs that the workflow gets triggered by the event, and then the workflow goes off and runs the jobs, which has the steps in it. Steps then are what we're calling the GitHub Actions. So this is really kind of the environment around the actions. The actions themselves are kind of what goes into the steps there, and the actions are sort of separate packaged up pieces of functionality, as we'll talk about in a moment. So we have different steps in there, and we can have actions within those steps that run. And here's an example on the right-hand side, a little hard to see probably with the small print, but there is actually an actions checkout here. So there's a steps keyword, and then there is actions checkout at V2. So that is an action or a process that somebody has created that does a checkout. basically out of GitHub. The V2, version 2. This is what actions look like. Actions are really those pieces of information in there that set up to do some specific piece of functionality in there. Now, the other piece that we need to talk about in the environment sense of GitHub Actions is the runner. The runner is really just a server with GitHub Actions runner app on it. It's a machine to execute the processes on. It can be either something that GitHub hosts or it could be a self-hosted runner. So the runner listens for available jobs. It has that agent piece on it, that Actions runner app on it. And so it listens for jobs, and then it listens for, then it executes the steps on the machine. So we have, again, the workflow with the different jobs, the event that triggers that, the steps that are available in that, the actions in there. And then when it gets triggered and when it actually runs it on a runner. Again, these can be GitHub-hosted runners, hosted by GitHub, or they can be self-hosted runners. And actions then have different runs of the actions and, of course, log results as well. So the basic way that workflows are triggered from a high level is some event happens in a particular GitHub repository. Again, the actions are tied to a repository. So an event happens in there. The resulting event has some sort of a SHA reference, the SHA-1 being basically like the checksum of the content that's going into GitHub. I'm sure you probably all have heard the SHA-1 value talked about. Then we have a Git reference. The reference could be like a branch or a tag or whatever area we're working in the repository. We have this .github workflows. That's the area where these pieces are stored. So if you go and start looking for the workflows and stuff, it'll be in that .github workflows area, and it gets searched for files that match that area they're working in. In other words, the branch or the area that we're looking at. The workflow files for the commit and ref are inspected, and then we'll look at the on piece to see, do we match the conditions that we're looking for? Are we doing the kind of event here, a push, a pull request, that kind of thing that we are matching on here and looking for the workflow to execute on? Is it on the right branch if we have a branch specified? That sort of thing. So the on piece then says this is where we should execute it when these conditions are met. Then the workflow gets run from there. So overall, kind of the big picture, in your GitHub repository, you have the .github directory, you have the workflows directory, you have your workflows in there, and you can have more than one workflow defined. You have workflows have jobs, and I'll just kind of click through these very quickly. And then you have an event, and whatever workflow it matches to, it causes things to run in runners and execute the actions. So that's kind of the high level picture of how the environment fits and how GitHub Actions actually fit into GitHub repositories. Let's go and talk a little bit about some other things you can do with actions. You can edit actions. You can use the GitHub environment to look at information from the actions, to look at output. You can also go in and edit them. In the actions menu on that top level, just as you have the code menu and such, you also have an actions menu. And that actions menu will list all the workflows you have. The workflow is that higher level piece that contains the jobs and the steps and so on. So you can pick the workflow you're interested in. You can also go into this, click on this link here, which is the file, the actual YAML file that contains your workflow. Click on that, and then you can go in and you can actually edit the file in GitHub itself, and you can go in and make changes to the code in there. Of course, you can pull it down locally as well and modify it and put it back out there, but the point of this is that you have a kind of a full environment in GitHub itself to be able to work with these. On the right-hand side is a way that you can search for public actions. These are all kinds of different actions that people have set up. You can see things like download a build artifact, upload a build artifact, kinds of things. These are public actions. So actions become a way to package up this functionality that can be shared in GitHub and can be pulled into your different workflows and used. If we want to update an action or a workflow with a pull request, it's the same as any other kind of pull request. We go in and we would edit the file, and then we would go in and confirm the merge, create the pull request, and we can see it run. So we'll actually try to validate then to make sure that the action is valid, the same way that it would do for something else that you're trying if you had CI/CD connected up to it. So we'll go through and validate that, and you can also go in and drill in and see where any errors are. So again, you have that full environment inside of GitHub to be able to interact with any changes or such that you're making to actions there. Searching for a public action, so you have actions already before you ever create your own action, and you can create your own action, as I'll talk about in a moment. You want to probably search out there to see if there's already an action that somebody has put together that you could pull in. You know, you almost might think of these like plugins or something to some other systems there. It's functionality that people have put together and made available to use. At their core, they're just going to be the same kind of things you have already with YAML files to specify the action piece and then some underlying code to do whatever is needed. So you can go out and you can search for public actions. You can type in there in the window in GitHub, upload, for example. Upload to find the one that says upload a build artifact. And then you can go out and get more information to it, and you can actually link out to it on the web, and you'll find things like what does it use? It uses actions upload artifact, meaning which one do you pull into your workflow if you want to use this? What kind of parameters do you need, and so on. So there are a ton of public actions out there that you can already take advantage of, and chances are the thing you need, probably somebody has already done it, unless it's something more kind of strict to your environment. You can actually go out and then click on that and view the marketplace action. So the marketplace is the main place where you have these actions that you can go and get from. Everybody has a marketplace, right? Well, GitHub Actions are no different. There's a GitHub marketplace action. And you can go out and you can look at that. You can see, you can pick the versions on the right-hand side. You can go in and drill into the code and see what's actually happening there. It's all open source. So you can look at the action and find out information about it. You can also create custom actions. If you don't find an action that has what you need in it, you can create your own custom action. And you can also customize community actions. So you can start with a public action out there from the marketplace, from that community, and you could bring it in and then modify it yourself. You can integrate with any kind of public API. You can run it directly on a machine or in a Docker container. You can define the inputs, outputs, environments. It does require a metadata file. So all the GitHub actions will have this action.yaml file, action.yml. That's the interface for the action when you're defining a GitHub action. But underlying that, you can have different kinds of code. So it gets defined and it gets tagged with a label. We saw that at v2 for the uploading an artifact. And then we can, to use it, we simply put it in .github workflows and then use it in there. So if you want to know what this looks like, kind of the process, we create a GitHub repo for our action. We clone it down, create the files that we need, add an action YAML, which is, again, that interface file that allows it to be used as an action. Do a commit and tag it with some sort of a version number like we saw. Typically it's like a V1, V2, that kind of thing. And then push it up with the follow tags to make sure the tag gets in there. And then in your workflow file, you would simply say whatever the condition was, like on push sort of thing, jobs and runs on whatever it's going to run on, the kind of runner. And then the steps would have the information about your repo and your action. So the uses here is what calls out that it's a separate action there. That's the one you put in your repository, your action name at some tag. So if you had like your own separate GitHub enterprise area or something, you can make your own repository with your own GitHub actions to use in that. So when we talk about custom action types, to help you understand a little bit more about what's involved in a custom action, there's a couple of different types that they support. One is a Docker custom action. So a Docker custom action packages up the environment with the actions code. This gives you the most control because it's running in a container and you have everything configured in that container to be able to control the environment exactly. The environment can include specific OS versions, config, tools, whatever. It runs only on Linux runners with Docker installed, so your runner system has to be Linux in this case. It's slower due to the cost of building and retrieving the container, because you're going to have an image, and then when you actually go off to run it, it's going to have to start up and build and run that container. And then GitHub is going to build an image from the Docker file and run it in a new container. So when you have this, you would have Docker plus a Docker file plus some kind of action YAML. So you have the Docker file that describes the container you're going to build and execute, just like any other container. And again, then you have that action YAML file, which is what actually defines how that can be used. Another type is JavaScript. So we can have JavaScript ones which run directly on a runner for any of the Mac OS, Linux, or runner or Windows pieces. And this separates the action from the environment. So you can use something like Node.js there, and it needs to be pure JavaScript, no other binaries available. And it can use the binaries already on the runner. So it needs to be JavaScript as far as the code in there. So you could have like an index.js, and then you could have an action YAML that ties into that. So if you could do something in JavaScript this way, then you can tie it into an action. Again, as long as it has that action YAML, you're good to go. The other kind is called a composite. Composite combines multiple workflow steps into one action. It can run on any kind of runner, any of the systems it supports. And you could have a simple shell script, for example, an action YAML. This is the case, I mean, with just a simple shell script, just a couple of commands to run or something like that. So you can keep it very simple. So different ways to actually implement the functionality of an action. As long as you have that action YAML that maps it back to what it needs and describes it, and you can put it in a separate Git repository, you can use it in your workflow. So it's really not that bad. There is an Actions Toolkit to provide packages for more easily creating or working with actions. It has functions in there to be run in code, such as a core set of actions or the core actions that can be used to do things like set output, in this case color, or it can run as workflow commands. So you can actually have it as calling these core functions to do this, or running them as separate commands in the workflow. There's the GitHub Actions here. You can see different actions you can choose from, different categories, like the core set of actions for inputs, outputs, results, actions exec, and so on. I didn't bother to try to show more of them, but you get the idea. There's different groups of actions you can choose from to draw on as you're creating your own actions. Some of the packages here, they're stored actually, if you drill into this separate areas, like here's the one for the Actions core in GitHub. You can see the Actions Toolkit there and see a little bit about the Actions core set. GitHub Actions have some environment variables you can also use. The GitHub workflow, run number, so forth. You see a lot of them in there. Basically, this is default variables or default environment variables for each run of an action. As with a lot of other processes, they'll give you a basic configuration automatically when you're running their processes. So this gives you basic settings that GitHub fills in for you when you're running your actions. They're case sensitive. They can be for a step, job, or overall workflow. For example, you can see here on this little section here, we have a level that we have an environment variable level admin, and then we check to see if that's the case, and check to see the user ID and so on. The viewing the workflow run history, we talked about this briefly before, but basically if you go into the actions menu, you can actually select a particular workflow and then see the run of it here, and you can drill back through it. So it keeps information around about which actions, about the runs of the different actions. You can look at a specific one, you can drill into it, and you can get into the logs and see debug information. When you're looking at the logs, you basically just click on the workflow in the list of workflows, click on the step you're interested in, look into that. There's a little gear icon up here in the upper right that you can look at, and you get options such as timestamps to see when the timestamps of when things run. You're also able to view the raw logs. There's an entry here. So you can go in again through the GitHub interface and see what was being executed and take a look at what was happening in there to do your debugging. You can also set up debug messages and such. There's ways to do that in your action. We're not going to have time to go into that today, but there are ways to do that as well. The actions runner, let's talk about runners for a minute. So the runner is the application that runs a job from GitHub Actions workflow. Basically, you have the runner app, then you put on a system, and that's how it knows to be able to execute the different workflows with the actions in there. GitHub does provide a set of virtual environments for actions for hosted runners. Again, you can have a runner that is hosted by GitHub or that is hosted by you. Here's the available environments. See, we have ones for Ubuntu, Mac OS, Windows Server, and so on. These are virtual machine images of Microsoft hosted agents, in this case for Azure pipelines. Now, one thing about this, and I'll refer to this a little bit later on towards the end when we get to talking about cost, there is a higher cost actually for doing the Mac ones especially. For Mac and Windows, surprisingly with Microsoft, but there is a higher cost that they charge you for running those in there as well. So GitHub hosted versus self-hosted runners. So the basic idea here is if you want to be simple and quick and easy to use one of the GitHub runners, okay? We'll talk about cost a little bit later on, but you can do a certain amount with it. It's hosted by GitHub. It runs the GitHub applications automatically, the runner application. There's Linux, Mac OS platforms. It is quicker and simpler, owned by GitHub, so they're managing all of that in the background for you. You don't have to worry about that. You have free minutes on GitHub planned when you have with a cost for any overages. And then you have installed packages, tools, automatic updates that happen, and then the implementation is a virtual machine. Self-hosted, as you might imagine, any system configuration that you want to use, you need to make sure you put the GitHub runner application on it. You can make it configurable as you need to. The cost, of course, is free to use with Action, but you're responsible for any other infrastructure costs that you assume in the course of running it. It's only for self-hosted runner applications, automatic updates, and of course it can be virtual or physical. So if you need a different sort of a setup, or if you already have machines that you can use them as a self-hosted runner. If you want to just do it the easiest way, simplest, quickest, and you want to have everything already taken care of you for it, you don't have to, you can just use the GitHub hosted runner systems. So another piece that GitHub Actions provides for you is storage of what we call artifacts. Actions allow you to persist data after a job has completed. It could be any kind of artifact, a jar file, WAR file, something like that. It could be a document. It could be whatever makes sense to persist. So an artifact is just a file or a collection of files that get produced during your workflow run. Maybe it's something that you compiled if you're doing that sort of, like a CI/CD sort of thing. Or maybe it's something you want to be kept around to share with another workflow, any kind of output, log files, those kinds of things. Actions artifacts can be uploaded with a workflow run. You may remember the upload artifact, one of the actions that was available there. They can be shared between jobs in the same workflow. Remember that the workflow is that overall encompassing piece. We could have multiple workflows in a GitHub repository, but within the workflow we have jobs. So the artifacts can be shared between the jobs. For example, if you were doing a workflow for CI/CD, you might temporarily put artifacts in GitHub and store them there. It's visible in the UI, as we see here. This is basically taken from the GitHub workflow page, and you see we can see I uploaded this greetings jar artifact here. They're retained for 90 days by default. You can tweak that, of course. There's going to be a charge for it depending on how much storage you need to use and those kinds of things. But it's a convenient way to be able to store files, especially if you have multiple jobs that need to use the same artifacts or have them readily available for them. So what are the limits? So we talk about GitHub Actions. Let's talk a little bit towards the end here of this about some of the limits that you run into, and some of the cost considerations. So in terms of the limits, the job execution time, each job can run up to 6 hours of execution time. At 6 hours, it's going to terminate the job and mark it as failing to complete. The workflow runtime, each workflow run is limited to 72 hours. Once you get past that, the workflow run gets automatically canceled. API requests, you can call in the APIs from your workflow, from your jobs and such. You can execute up to 1,000 API requests in an hour across all the actions in there. Past that, additional API calls will fail and likely bad things will happen. So they keep that in mind. Concurrent jobs. The number of concurrent jobs depends on your plan, but past a certain limit, additional jobs are queued. So you can see here, I copied this table out of some of the documentation. The GitHub plan, GitHub Actions are available pretty much on any plan you have, and you get a certain amount. It's just when you go over that, then you have a certain cost incurred with that. So total concurrent jobs, 20, 40, 60, 180 for depending on your plan type. Maximum concurrent Mac OS jobs is much smaller. Mac OS, I guess their hardware stuff, it's much more pricey, so they charge you a premium, or they scale down the number you can do, and also charge you a premium for the number of minutes you can use. How much does it cost? Part one, it's free for both public repositories, self-hosted runners. For private repos, each GitHub account gets a designated amount of free minutes in storage. Above that, the usage is going to be controlled by spending limits that you can set up for it, or your company can set up for it. The minutes reset every month, but not the storage. So you can see here on the storage, there's a certain amount, again, for the free, the pro, the organizations, the team, and the enterprise, and it goes up as you're going along. The minutes per month that you're allowed as well. So you get into this amount here. If you're getting into the enterprise stuff, you're getting into the higher levels, but also presumably the higher cost as you're paying for the plan. Part two, the total storage is actions, artifacts, and GitHub package. So this total storage that you can consume in there is the amount for the artifacts that you can store in there, as well as packages. Packages are basically containers or dependencies or other things that you need to pull in with your process. The storage usage is calculated based on an hourly usage during the month. So they basically look at how much storage you're using every hour, and then they factor that in and charge you based on that. So if you leave something sitting around for a long time, you're going to be paying for it, basically how much storage you're using on this per hour basis. The, excuse me, the runtime here, per minute rates, and as I mentioned earlier, if the jobs run on Windows or Mac OS, you can see there's a multiplier they have. For Linux, it's 1. For Windows, it's twice as much. They count, if 1 minute counts for 2 minutes. If it's a Mac OS, 1 minute counts for 10 minutes. So be aware of that. If you're doing the Mac OS, you may be better off trying to actually do something different, or at least do it on your own runners. Just a quick note here, there are lots of training options out there, but if anybody is interested in learning more about this, there is a workshop I'm doing for No Fluff Just Stuff in December. If you're interested in checking that one out, it'll be a virtual. It's going to be like probably a 3.5 hour hands-on. We'll do like 6 different labs and go through GitHub Actions, give you and you'll be able to have something in GitHub working there. So as I said, this is not the only one, so I'm not pushing this particular one, but if you're interested in some hands-on training, maybe check that one out as well. All right, that's it, I think. Sorry, I went through that kind of fast, but questions? Thank you, appreciate it. Yes, sir. So just for the folks on the virtual side, the question was, is this meant to replace TeamCity, Jenkins? Looks like it's pretty comprehensive. Well, you know, there's the whole thing about is Microsoft taking over the world, right? But I mean, it certainly is the case that they want to have something for you to use as an alternative to these other things. Certainly you can use like Travis CI, those kinds of pieces in there to work with GitHub repositories as well. But one of the things here that they'll emphasize in the documentation, and Brian was emphasizing yesterday, was that this is not just about CI/CD. CI/CD is the most common use case, but it's really about automating anything in GitHub. And that's the kicker though, like I said, this is only about GitHub repositories. So certainly if you are using GitHub repositories and you're comfortable with the cost factor and stuff, there is an appeal to be able to do your CI/CD kind of inside of GitHub itself and to spin that up and have it run automatically. So is it intended to replace? It's certainly intended to give another option if it fits in the GitHub space. Yes, of course. That one? Yeah. I think O'Reilly also has a GitHub Actions thing as well, but this one, like I said, will be a hands-on sort of thing. Other questions? Actually, it's pretty easy to try it out too, and I would encourage, yeah. Yeah. Yeah, basically like, yeah. You can call it the GitHub API, yeah. Okay, awesome. Anybody else? Yeah. I've done a little bit with GitLab runners, but honestly, it's been a while. We did early on. I had where I work, my day job, we did a comparison with that. And I think GitHub Actions are a really nice fit, again, if you're working in GitHub. Just like GitLab runners are probably a very good fit if you're working in GitLab. Outside of that, you're probably maybe better off with something else as well. Or if you can't, if you don't have like an enterprise account, this is appealing from the standpoint of, I'll give you a sort of experience. We had some folks that looked at it, everything we were doing in Jenkins and stuff, and they were able to take GitHub Actions and do things, that we had taken probably weeks to set up in Jenkins, getting all the plugins right, getting everything set up, and they were able to do it in a couple of days with GitHub Actions. It's really pretty intuitive once you kind of get the lay of the land with the workflows and the steps and that sort of thing, and especially because there's already so many other actions out there in the community. So I don't know enough about runners to really feel like I'm qualified to comment on that part of it. I assume the same sort of thing applies. There's probably a lot of GitLab runners and stuff out there as well. But if you're doing it in GitHub, again, this is a really good way to go. Yeah. Other questions? All right, thank you again, everybody, for staying around. I hope it was useful to you, and hope we get to see you again at some point at another conference. Thanks, everybody.